This video is for section 7.2, and what we're going to look at here is what are our properties of exponents when we divide monomials. Okay, so when we're dividing monomials, okay, we have this quotient of powers rule. Remember, quotient means to divide. So if we are dividing and the bases are the same, subtract the exponents. All right, so now we've got this new rule that says when you divide and the bases are the same, subtract the exponents. So you want to take the top exponent minus the bottom exponent. We also have a second rule here that says the power of a quotient, which basically is the distributive property for exponents when you have a division. So if you have a fraction raised to a power, realize that you're going to give that power to both the top and the bottom part of the fraction. Okay, so let's take a look at a couple examples and simplify. All right, whenever I am doing these kind of problems, I always like to do them and keep it very organized. For example, I focus on numbers with numbers and each individual variable with its corresponding variable. All right, so in this first problem right here, when I see a to the fourth over a, I'm not looking at the whole big thing. I just saw the a's. Okay, so I'm thinking a to the 4 minus 1 power. I subtracted because we're dividing. Remember that a on the bottom has a power of 1. Then I've got b's, and I know that b would be 7 minus 2. And this leaves me with a to the third, b to the fifth, and I'm done. It's literally that easy. All right, you just have to be able to focus on doing one thing at a time. Now, a second example that's a little bit more complicated, if you notice we have the power of 3 outside of this fraction. I have two different options that I can do. Option number one is simplify the fraction first and then do the power property, the power of a quotient. Option number two is distribute that power in first, then worry about the division property. Now, if I distributed that power in, that means I got to distribute it to all 5 pieces that are in there. So let's see if we can simplify this first. All right. First thing I'm going to do is focus on the numbers. I have 2 over 3. 2 over 3 I can't simplify. All right. I have a to the third. I'm going to extend. Let me rewrite this a little bit. I'm going to write a fraction bar here. 2 and 3 stay there. Now I have a to the third, but no a's down on the bottom, so I just leave that a to the third up on top. I have b's on both the top and the bottom. Subtract the exponents. 5 minus 2 is b to the third, and I'm going to put that up in the numerator. Now I have to take this whole thing and raise it to the third power. All right, so what does that mean? Now I have to remember stuff from the last section. That means I have 2 to the third. I have a to the third to the third. I have b to the third to the third. And on the denominator, I have 3 to the third. All right, I want to clean this up now. 2 to the third is 8. 2 times 2 times 2 is 8. And what about the next one? A to the third to the third. That's power to power. You multiply the powers. A to the ninth. B to the third, multiply the powers, b to the ninth. In the denominator, I have 3 to the third. That's 3 times 3 times 3, which would be 27. All right? And that simplifies. Now remember, if you could simplify the numbers within the fraction, you would do that. All right, so the next thing we want to talk about is the idea of a zero exponent and a negative exponent. So let's start with the zero exponent. The rule is very, very simple. Anything raised to the 0 power is 1. But it's only that individual piece that is raised to the power of 0. Okay? Negative exponent rule says if you have a negative exponent, just simply move it to the opposite of where it starts off. So for instance, a to the negative n is really a to the negative n over 1. I'm going to move that a to the negative n down to the denominator, and that simple move makes the power become positive. Now, if you look at it from the other perspective, what if you have 1 over a to the negative n? To make it positive, just move it up to the top of the fraction. And that's how I get a to the n. All right, so let's take a look at this example and see if this makes sense. I want to think of everything in pieces. So the first thing I'm going to think about is 4 over 16. I know I'm going to be able to simplify that. I'm going to come back and simplify it in a little bit. Now I have a's. I have a to the negative third over a to the second. I'm going to use my division property and subtract, and that gives me a to the negative fifth. I look at the b's. I have b to the sixth and b to the sixth. I have b to the 6 minus 6, which is 0. All right? And then I have this c to the negative fifth, but it's really 1 over c to the negative fifth. I know this might get a little bit confusing. Make a single fraction bar. Start with the numbers. 4 over 16. 4 over 16 simplifies to 1 over 4. I have a to the negative fifth, and that's a numerator. To make that exponent become positive, I move it downstairs, down to the denominator. B to the 0. B to the 0 is really saying there are no b's. So I don't have to write a b anywhere. I go to the 1 over c to the negative fifth. Because that's a negative exponent, I got to make it positive by moving that up to the numerator. So that simple move of moving it either up to the numerator or down to the denominator when you have a negative exponent is what cleans that up and makes the exponent positive. You must have positive exponents in your answers. All right, let me know if you have any questions.